Welcome to G Fun Facts Online, where today we're talking about the planets that shouldn't exist. For most of history, we thought we had it all figured out. Our own solar system was the perfect model. Small, rocky planets close to the sun, big gas giants farther out, everyone moving in nice, flat circles. This idea, called the nebular hypothesis, basically says that stars and planets form from a giant, spinning disk of gas and dust. It's a tidy, elegant picture. But it turns out, the universe is a lot messier, and frankly, a lot weirder than that. As we've pointed our telescopes into the dark, we found a whole gallery of cosmic oddities. Planetary systems so bizarre they've been called impossible. These aren't just curiosities. They are clues that are forcing us to rewrite the entire rulebook on how worlds are born. Let's take a tour of the impossible. First up, the hot Jupiters. Imagine a planet as big as our Jupiter, but instead of orbiting way out in the cold, it's snuggled right up against its star, completing an entire year in just a few days, or even hours. According to the old rules, gas giants can only form beyond a frost line, where it's cold enough for ice to exist. Finding one next to a stellar furnace is like finding a polar bear sunbathing in the Sahara. A crazy example is KEE-ELT 9b, the hottest exoplanet we know of. Its daytime temperature is over 4,000 degrees Celsius, hotter than many stars. The star's radiation is literally boiling the planet's atmosphere into space, leaving a trail of vaporized metal in its wake. If that wasn't strange enough, how about zombie worlds? In 1992, astronomers found the very first confirmed exoplanets, named Poltergeist and Phobator. But they weren't orbiting a normal star. They were orbiting a pulsar, the super-dense, spinning corpse of a star that went supernova. How could any planet survive that kind of cosmic explosion? The theory is, they didn't. These are second-generation planets. True zombie worlds born from the dust and debris left behind by the supernova. They are new life, rising from the ashes of the dead. Similarly, we've found planets that survived their star's red giant phase, when they should have been completely swallowed. The planet Hala orbits its star Baekdu so closely, it's a miracle it's still there. The best guess is that Baekdu was once a pair of stars that merged, a process that somehow saved Hala from certain doom. And what about planets from a galaxy far, far away? The famous double sunset on Tatooine in Star Wars isn't just fiction. We found plenty of planets orbiting two stars at once. Kepler 16b proved that stable planets can form in the chaotic gravity of a binary system. But why stop at two suns? There are systems like Castor, with 6 stars all orbiting each other. While we haven't found a planet there yet, can you imagine the sky? The cosmic zoo just keeps getting stranger. We have cotton candy planets like WASP 193b, which are as big as Jupiter but have almost no mass. We have planets on wild egg-shaped orbits that swing from one extreme of their system to the other, likely scarred by ancient gravitational battles. There are planets where it rains molten glass sideways in winds blowing at 8,700 kilometers per hour, and others where the clouds are made of liquid metal, raining down rubies and sapphires. And then there are the loneliest worlds of all, rogue planets. These are cosmic orphans, kicked out of their home systems to wander through the dark of interstellar space, forever alone. So how is any of this possible? Well, these impossible worlds are just showing us our old rules were too simple. To explain things like hot Jupiters, scientists developed the theory of planetary migration. The idea is that these gas giants form far out in the cold, but then slowly spiral inward over millions of years, locked in a gravitational dance with the disk of gas and dust around them. For the weird orbits and the rogue planets, we have a process called gravitational scattering. Think of it like a game of cosmic billiards. Early in a system's life, planets can gravitationally push and pull on each other, flinging one into a strange orbit, or even right out of the system entirely. Even our own solar system probably had a chaotic youth like this. What this all means is that our solar system isn't the blueprint we once thought it was. It might just be one of countless possible outcomes in a universe governed by chance, chaos, and gravity. These impossible discoveries are the most important ones, because they show us the true, mind-boggling scope of nature. They force us to look beyond our quiet cosmic neighborhood and accept that the universe will always be stranger and more wonderful than we can ever imagine.